panel. So this number of panels, 27 of them, were handpicked all around the world, representing different regions, as you can see here, from North America, Latin America, Asia, Sub-Saharan Africa. So they actually provide scientific and technical advice and guidance on how to produce global soil reports, as well as to enhance the functions of the Global Soil Partnership. Okay, so this is the current GSP action framework, which has been outlined since 2022 to 2030. And you can see here some of the main global challenges that the GSP is also facing is climate change, biodiversity loss, land degradation, food insecurity, pollution, and water scarcity. And all this somehow is intertwined with soil. So in order to address these issues, I'm very proud to be part of the ITPS, whereby we provide guidance as well as advocate science related to the thematic soil symposiums, which we have adapted mainly on soil carbon loss, pollution, erosion. We also help on looking at global assessment reports produced by the Global Soil Partnership. We have already produced a status of the World Soil Resources Report in 2015. And this year, you are very lucky that you would be seeing the second edition of it, which will be launched this month. So besides the work that we do here, the ITPS also comes out with ITPS soil letters such as this in this slide. So you are more than welcome to visit the FAO website to know more about the good work which is done under this entity. So these are some of the pictures that I like to share with you. Some of us, me and Ms. Nomani, were in the fourth panel for the FAO ITPS from 2022 to 2025. I'm very glad and humbled to be re-elected again to be in the same panel from 2025 to 2028. So these are the ITPS members all around from Asia. So we have friends from China, Dr. Zinhua Peng, Prof. Jahiruddin from Bangladesh, Dr. Vel Murugan from India, and of course, Ms. Dr. Dokmani Suwani from Thailand. So looking at the work that have been done by GSP since its commencement in 2012, the Global Soil Partnership, with the assistance of ITPS, have produced many different reports related to World Soil Charter, voluntary guidelines on sustainable soil management, soil assessment reports. We have also advocated a lot of promotion as well as the importance of soil through the World Soil Day, which is held every 5th of December annually. So this year, you would be looking forward to the status of the World Soil Report. And of course, there has been a recent report on the production of cocoa and also on the role of cadmium in these plantations. So feel free to visit the website given here to look at what have been done by the Global Soil Partnership. So the status of the World Soil Report itself was not an easy feat, because it involved more than 280 authors from 75 countries. You can see the number of authors from different regions. And it took us almost 4 to 5 years to write this very important report. So the work which would be presented in the status of World Soil Report is very special because it's very close to heart. It will be looking at a regional context from where you are from, and also give you ideas where else that we can actually improve our sustainable soil management strategies. I would also like to record a big thank you to all the authors who have actually contributed, even from Asia itself. There were several of them who were willing to come in front and to assist in writing of the report from different agencies. So, what does the status of the world's soil report has? So, mainly, I'm just giving a summary what it will be content. It will summarize the linkages between the soils and the sustainable development goals. Of course, we would be addressing the major soil threats which is affecting the soil functions that we have. It will provide evidence on what are the direct as well as indirect drivers of soil threats, identify sustainable soil management practices, highlight several strategies to facilitate how we can adopt sustainable soil management in a better way. And as I mentioned, it will provide a regional overview on how are the soil threats are and how we can improve them. Of course, this report differs from the 2015 report, where the 2015 report was more of a management-based approach. So we've got news that the report would be launched in the UNCCD COP17, which would be held in Ulaanbaatar, Mongolia. So please save the date. Please mark your calendar, 27th of August. So once we have more information on the link, we will be able to provide to those who are interested to attend the launch of this important report. So, ladies and gentlemen, what are the major soil threats in Asia that we are looking at? So, under the Global Soil Partnership, we have identified 10 different soil threats. Of course, the most difficult or maybe the most impactful ones that we have found in Asia are mainly on soil erosion, the change of soil organic carbon, as well as soil sealing and land take. So what we want to also share here is that the way that the regions are divided for FAO is according to the map that I'm showing you in this slide, where we have North America, Latin America, and all other regions. Of course, Asia being a very big region, we have a representative of work or case studies from South Asia, East Asia, as well as Southeast Asia. Excuse me. So the regional assessments, which will be at the end of the report, would be looking at on the current soil management, which is being done at regional level, whether it is sustainable. So this will be categorized as either it is poor, very poor, fair, and etc. And we will be also looking at the trends related to the soil trends, where whether it's improving, deteriorating, or even stable since the last it was assessed in 2015. So what are the key messages that we want to take home from the status of the World Soil Report resources? We know that we already have the voluntary sustainable soil management guidelines which have been produced by the FAO. But however, the adoption of these guidelines are either low or at moderate levels. This has actually affected and has brought effect of degradation cascade, where some of the soil threats are interlinked. If you can see, when we talk about soil organic carbon, it is related to soil erosion. When there is erosion, somehow we also lose our soil organic carbon. And we look at, let's say, waterlogging, like when I showed in the previous slide, it is related to soil compaction. Of course, we have all these soil threats here, but one of the challenges that we have is that the knowledge action gap. The scientific knowledge that we have actually compiled is quite substantive, but it is not being applied at scale. So this is where that we need to see how science can connect or bridge with social and policy integration. We want to see how the work which have been done can be translated into sustainable solutions whereby it gives long-term social benefits as well as receives strong policy support from the governance which is looking at it. And this would not be possible if we have unless we have a proper engagement with our stakeholders, we give the right information, as well as we have the modality of governance which oversees this in order to find somehow halfway or a successful impactful work related to sustainable soil health management. So let's move at the work or even the scenarios that we have in Asia. So these are some of the dynamics which are driving planetary changes. If you can see the figure here, by the year 2050, Asia will be the most populated region. We would be at least 5.3 billion. Having said that, we also have to understand with the increase for population, there is a big demand for food. And this is where it will drive land use change. So when there are land use change, we would expect that it would be also affecting soil health. Having said that, let's also look at the cost of global warming that we are experiencing. So when we're talking about climate change, everything has a cost. We are in the midst of an El Nino where you can see that there are so many wildfires happening in other parts of the world. The temperature here in Asia itself, it's so high, and it has been projected that we lose a lot of money related to damages due to global warming. This includes on climate disasters, flooding, what else, thunderstorms and things like that. And these climatic drivers are also affecting the increase in the global sea level. We do see a projection of increase of sea level rise, which is affecting the coastal ecosystems. And when we look on the other side of the coin, excuse me, there is also reasons to believe that geopolitical tensions or unrest is also affecting the soil health. And please go to our FAO website and have a look at it to see the recent report or the ITPS letter on what is the cause of the soil changes related to conflicts, areas in conflicts. So many years ago, when we had the green revolution in Asia, we were looking at high yielding varieties. We were looking at introducing genetically modified or improved germplasm or even varieties in order to increase the productivity. And we were also depending heavily on synthetic chemical fertilizers. This has also cascaded into expanding irrigation areas in order to provide irrigation for agriculture areas, and mechanization has also increased the its in the in mechanization has also increased in many agricultural areas in order to increase productivity and yield related to agriculture. So what has happened is that due to the overusage of all these synthetic chemical fertilizers, mainly we have had issues related to skewed chemicals and nutrient mining, whereby utilization of nitrogen fertilizer has removed some of the trace elements from the soil. Excessive usage of fertilizer has also caused soil acidification. There's also toxic salt due to the buildup from irrigation. Of course, mechanization, despite eases a lot of our work, it has also created hard pans, whereby it has impeded root growth. And we have also lost a lot of soil organic matter due to erosion. However, now what we are looking at is that how can we fit in the jigsaw puzzle related to the importance of soil in food security as well as climate change. So if you can just have a look at this figure, we can totally understand that soil sits at many different sustainable development goals. Even the ones which I have marked red is more related to food security and climate change, such as flood regulation, climate regulation, provision of food, fiber, fuel, sequestration of carbon, nutrient cycling, water purification, and soil contaminant reduction. There are also other roles that soil play besides this, where it looks at the foundation for human infra, provision for construction materials, habitat for biodiversity, and many more. Some key messages that I would like to share from the Climate Change 2023 report, which was produced by the IPCC, was that the application of soil carbon sequestration, apparently it has a much more lower cost, about 45 to 100 US dollar tons CO2 per equivalent. And this can be done with various strategies such as afforestation, reforestation, improve forest management, agroforestry, and soil carbon sequestration potential, where this can be an eminent method in carbon dioxide removal. It is also outlined that there is a need for conservation of high carbon ecosystems, such as what I have presented before this, the peatlands, wetlands, of course, mangrove forests, and rangelands. And this has very immediate impacts. We are also looking at new strategies on how the coastal or the ocean ecosystems can actually sequester carbon via blue carbon in soil, sediments, and seagrasses. So what do we need to do? Excuse me. So the first row of the images that I've shared with you here is actually looking at what we can do from the context of agriculture. Of course, we can do conservation tillage, we can do split tillage, mulch tillage, where it reduces the breakage or the loss of soil structure. It improves carbon sequestration, where you don't allow so much of decompositions by the microbes. We can also look at different types of nitrogen fixing cover crops, such as your gliricidia, your cowpea, your mung bean, your vetiver grass, where it can provide nitrogen for the crop that you are planting, as well as fix natural nitrogen from the atmosphere. And what you do with the waste that you produce from the agricultural produce once you have collected the yield. So many have also advocated on turning them into either compost or even biochar, where recycling agricultural byproducts would actually put in your biomass back into your soil and somehow increase the value or the soil organic matter potential in agricultural land. So in the context of forestry, what we can look at is on protecting the existing soil organic carbon ecosystems, such as either the peatlands or the mangroves. There have been a lot of studies which is also coming up on how we can rewet back areas which have degraded, mainly in peatlands. And in improved forest management, we are looking at how we can apply reduce impact logging, RIL, in order to reduce the impact of logging, soil compaction, loss of soil erosion when we are harvesting wood products from the forest. Besides that, there have been a lot of studies and reports showing that we would be also able to enhance the soil organic carbon pool in our soil if we do practice mixed species planting, whereby the diverse native trees can deposit organic compounds at varying soil depths and also via the root systems. And this would be more beneficial than only planting a monospecies. In areas where we do have potential wildfires, it is important to have certain strategies related to fire prevention management. So this is where that many stakeholders, besides the forestry, excuse me, besides the forestry department, they can work with the communities as well as the stakeholders who are there to reduce any occurrence of fire, which actually makes a lot of big impact related to the loss of soil organic carbon due to combustion. Of course, all this having said and done, these measures also have trade-offs and risks where soil organic carbon can also reach to certain saturation levels, usually after 20 to 50 years. We also have to look at the permanence of the soil organic carbon in whichever land that we are looking at. For example, if a farmer leases that particular land from the owner, and let's say if the owner wants to take back the land and change it into a different land use, there you go. The permanence of the land is lost there. And we also have to be cautious when we are doing re-wetting, especially in peatlands where there has been reports showing that there are methane emissions. So we also have to look how we can do this synergistically, but at the same time reducing the emissions of greenhouse gases. Okay. When the FAO has done a lot of maps, global soil maps related to soil organic carbon sequestration potential. So this is what I have pulled up from their website, where it shows that under a sustainable soil management scenario, where we do increase the carbon input, excuse me, at least about 20%, we can see benefits where the soil carbon sequestration potential in the Asian region can be within 0.1 to 0.2 tons per carbon per hectare per year, the potential of soil carbon sequestration. Okay, so this is another soil threat that we need to look at. As we know, there's a lot of work being done on soil erosion in many different countries. And of course, there are also sustainable farming practice which have been looking at either putting in windbreaks, strip cropping, terracing in order to reduce soil erosion. We have to remember that when the soil is lost, meaning that when the first layer of topsoil is lost, it also brings down its value, the humus, the organic matter. So these are the cascading effects that we can have when one soil threat is not being addressed. It will move on to also affect other soil threats that I've mentioned before. And in the forestry context, what we can do is on plans or strategies related to afforestation and reforestation. We know that trees gives many different benefits, not only for the atmosphere where it is able to absorb carbon dioxide. It is also able to reduce soil erosion. It is able to absorb water from the soil in order to prevent landslide. And of course, just today I read in one of the papers that some of the bacteria which live on the soil trunks are also able to absorb methane, which is another type of greenhouse gas that we are looking at in order to reduce related to climate change. So this slide will actually explain to you how we can put things hand in hand, whereby in a layman's context, we would call it agroforestry, where we do introduce a type of crop and a tree. And this is where studies have also shown that application of agroforestry models has been very impactful in many different regions. For instance, in the Himalayan mountains, it was able to reduce soil erosion almost 50 to 70%. Besides that, it has also given CO2 avoidance, almost 74.4 million tons in the Southeast Asian landscape. And in China, particularly, agroforestry has also become a heritage integration. So what are the major ecological impact that it has also had is mainly on watershed conservation, deforestation reduction, and also land rehabilitation. Of course, since we have an audience from many different regions, we also have to see what is the right type of combination of soil, of tree, as well as crop species that we want to allocate in our agroforestry model. So it's never a one size fits all, and this has to be also balanced with the climatic factors that each region possesses as well. So from the agroforestry models which has been implemented, we know that it has increased the farmers' revenue almost 40% higher. It has also buffered the smallholder risk, whereby they only look at one monospecies, and now since they have interpretation of different species, they are able to make income at a staggered way. It has also improved dietary diversity. Any models that we want to plan or even evaluate or implement has to come with maintenance. Whenever we are looking at conservation agriculture, we need to make sure that the way that we till our soil, the way that we reduce our tillage practice, what type of crop rotation that we want to implement there, the retention of crop residues, all has to be tested at least at pilot scale to see if it's doable in a bigger scale. Of course, we also have to look at the integrated soil fertility management, that is applying organic and inorganic nutrients according to site specificity. And continuous measuring and monitoring is also important to check whether your soil is healthy. This is not only related to the amount of yield that we are bringing back. Besides that, we need to look at the pest and disease outbreak, the crop response. Here, I would like to introduce the work which have been done by FAO and has been implemented in Malaysia and by the Department of Agriculture as well on the Global Soil Doctors Program. This program actually looks at how the farmers can do their own measurement and monitoring of their farm and be insightful of the results and how they can manage the soil health in their farms better. So if you want to know more, you can also contact the Department of Agriculture in your own countries. So what we have not seen so much is the effect of affected soil. You see, salts are very high in salinity. Whenever there is occurrence of sea level rise, we may not see with naked eye, but somehow the water seeps into the coastal land, also the agricultural land, whereby it has actually made the soil unproductive. So some of the measures which have been looked at is to use of soil tolerant crops or microbiota, which is either natural or genetically modified. We need to manage the irrigation in these areas in order to reduce the salinity of the water. You can do mulching, whereby it can reduce the evapotranspiration of the crops that you plant. You can try applying a small amount of gypsum or even putting in biochars, where it has shown that it can reduce salinity stress, especially in coastal ecosystems. So the FAO has also come up with the salt affected soils report in their website. If you have an issue related to salts affecting your soils, please go to this website and have a look of some of the strategies that you can implement in your farms. Soil acidification usually occurs in many different reasons, mainly for fertilizers. You see, sometimes when we have already applied fertilizers, we tend to reapply again for the second rotation, third rotation, not knowing that the first and the second rotation may already have excessive nutrients in the soil. So this is where that we have to use our fertilizer in a judicious way. We have to introduce crop rotation, diversify the plants that we are planting them. Judicious use of lime is also necessary if you want to reduce the soil acidification scenarios in your soil. You can do other things, you can try crops which are related to acid tolerant. In my ecosystem, the place that I come from, you can plant eucalyptus, meranti, guava rice. So all these are some of the examples of acid tolerant crops. You can also increase the use of biochar, but all this needs a bit of testing to see how much is needed, not to overuse and apply it in a blanket way. And you may not see the results that you want if you do not do some small pilot work in order to find out how much is actually needed for these areas and do the measurement and monitoring there. So the key takeaways from my presentation today is mainly to protect prime farmland, because we do understand Asia is moving very fast. There's a lot of issues related to land use change due to the demand of the population. If can prevent urban expansion into high fertility prime agricultural land, whereby it will reduce the capability of the soil to protect food security, because our soils are so diverse. There are so many soil types, and many of them behave in many different ways. So we need to understand that in order for us to treat soil judiciously as well, you need to protect your forests, especially where it is of a high carbon ecosystem. They play important roles not only for carbon, they are also a habitat for biodiversity, pollination, watershed. Try to avoid fragmentation of forests and also reduce monospecies planting. We may also rethink how we are channeling our subsidies, where we can look at how reallocation of blanket subsidies for chemical fertilizers, which may happen in certain regions, can be incentivized into schemes and carbon farming, where we encourage farmers to either to adopt integrated plant nutrition system, precision agriculture, Internet of Things, and application of organic amendments. As I mentioned before, permanence is so important, where despite whatever strategies that we are planning to do, whether it's short term or long term, we have to see the cost of securing the land tenure and see how we can actually make long-term investments in soil health. For instance, planting of trees, protecting the forest, application of biochar for carbon credits, and conservation agriculture. So let's define the ownership of the land from the beginning. So whatever efforts that we plan to or already in ongoing would be beneficial for everyone. And having said that, and also knowing that our soils are quite diverse, bear in mind that there is no one size fits all. There has to be a context-specific solution for soil management practices. It must be tailored locally, not globally. Sometimes it could be the farmer or the forester who is much more smarter, because they grow with the ecosystem that they live in, whether it's forest or it's agricultural land. They understand the solutions better than us. So before I sign off, I would just like to share with you some of the work which have been done by our team here in Forest Research Institute of Malaysia. So we do a lot of work related to soil chemistry analysis, as well as providing solutions on soil survey, CSR projects on planting. So if you want to know more, you can always scan the QR that I have given you in this slide. And of course, I would like to acknowledge our DG of FRIM, our division director, for giving us this opportunity to share some of the insights of our soil scientists from FRIM. My gratitude I would like to extend to David Lobb, who is from the 4th ITPS, who also helped with the slides related to the ITPS, the Malaysian Society of Soil Science, for inviting me to give this insight, our team in Soil Management Branch, all those who have logged in to listen today. I don't know how many of you all, but thank you so much for providing time and essence to listen to this presentation. If you want to know more regarding Malaysian Society of Soil Science, please feel free to visit their website or write to their secretariat with the email provided. And I would also like to announce that there is going to be the World Soil Day for this year would be tackling soil compaction, boosting food production. So if you are doing something related to this, feel free to share this in the FAO website, where it will be a global effort of celebrating World Soil Day to understand soil health in our earth. With that, thank you for your attention.
Okay, Dr. Jeyanny, thank you so much for to me for a very insightful presentation. Okay, and do you want to take some time to drink, because you have
Yes.
a few questions, but one I say I can read out here is that, will we get a copy of the presentation after this? So I think you can reach out to Dr. Jeyanny personally. There are things that she can share within her presentation, but as a handout, maybe she have to pick a few. But I think you can reach out to Dr. J. Is it okay, Dr. Jeyanny?
Yes, they can
Okay.
email me. I think shouldn't be a problem. You can put in or I can also type in my email there.
Okay, perfect. Okay, the next question is from Siu Teng Fu, which is, if Dr. Jeyanny can list out
For
the
this check
legume crop as
because
mentioned.
I want.
Sorry. Okay, sorry.
Was there a question?
Oh, I'm not sure. But again, somebody in the chat asked if you can list out the legume cover crops as mentioned in the, I think in the chat box. Okay. And then the next is okay. It's a bit small from my screen, so bear with me. We only have like 10 minutes with Dr. J. So in your agroforestry slide, in which you have mentioned that there is a 40% higher net revenue for smallholder or farmers, what was the baseline which is used? And do you have more information in this section?
Okay, thank you, Miss Intan, for the question. So the work that I presented on the agroforestry is more related to the Southeast Asia region, from Thailand, Vietnam, as well as India. So if the person would like to know more, I will be more than happy to share that link of the paper later with them.
Okay, thank you, Doctor. I missed one question. So, Doctor, in very dry or dead land, what can be done to rejuvenate the soil to make it healthy again and to make microorganisms live there again? Thereby, the land can become suitable for growing crops healthily. Thank you.
Okay. Okay, let me just increase the speaker. Volume. Okay. So thank you for the question, Miss Intan, from the participants. You see, this is where there is a very classic effect of soil degradation has happened. Soils have different capacity to hold water. Okay, so we need to find if the soil that the person has actually mentioned is be able to rejuvenate back. Either we do irrigation, we do planting of cover crops, and this will take time. So once we have introduced strategies part by part, irrigation, cover cropping, very minute types of crops which can be planted first, which may not need very high nutrients, and when the soil heals, only then you will be able to use it more effectively, planting much more bigger crops.
Agree with you, Doctor. I always like to treat soil similar as us
Yes.
humans. So when we are healthy, we can perform better. So there's another additional question. I think somebody answered, but I just want to know what is your opinion because it's related to your slide. What is meant by using good quality water in your slide, Doctor? What is good quality water?
Okay, you see, in Malaysia, from the context of Malaysia, we also have this water quality, So water quality measurements, whereby we look at water, whether it has heavy metal contaminants. Okay, so if possible, we would like to avoid utilization of water which is has heavy metal contaminants, which can go back into the plant by the absorption of roots, and it will be going to us. Let's say we are eating the plants, that would be a depository. We will become a depository of heavy metal in our system itself, and that can cause a lot of issues related to human health. Just to share one example, where I've also shared in the slide, where there was a study looking at chocolates, okay, where chocolates had high content of cadmium. So when they did the study, they realized that the fertilizers that they were using was actually had a high level of cadmium. So this is where that we need to look at the life cycle of the crop and where it ends up. So when the cadmium ended up in human, there were many issues where people couldn't their fertility dropped. They had other forms of diseases and things like that. So this is what I was trying to mean when we say clean water.
Okay, Doctor, the questions are really coming in.
Wow.
Okay, I have to. Okay, let's go with that because this is what we target to do. Within the chat box itself, there's a discussion happening. Somebody is answering, somebody is asking question, and other people is answering. So it's
Okay.
good. Yes. So okay, let me pick this one. Presentation mentioned that biochar can help with salination and acidification. How long does it take for improvement to happen? I think it's asking about how long will it begin to see the effect.
Okay, we just started our work on this. Just to share with you that we did a project about 2 or 3 years ago. One of our PhD student, she did some work on looking at how biochar was able to reduce the salinity in plants itself. So we did see some very convincing results, Miss Intan. So what I would do is that probably I would share with you the link of the paper, and you can pass it over to those who ask the question. On the long-term effects of it, we don't have the answers. You see, the grants that we get are designed to be finished in 2 years. or even a year. So if we are able to have a much more longer duration grant, we'll be more than happy to show the long-term effects of biochar on soil salinity.
I can relate to that because when we're doing research, the timeline is everything. We're trying to get the effect in long term, but then the grant is,
Yeah,
well,
only for that
yes,
stipulated time.
yeah.
So even as a researcher, we have these challenges where we need
Mhm.
to, make rapid, quick results and report what we can first, and then look out for other grants which can actually help us in the, near future.
Okay. So we have about 3 more minutes, Doctor. I think I have to quickly select questions. Okay, let's see this. Thank you very much, Dr. Jeyanny, for very interesting sharing. I would like to know on the reporting in UNCCD and FAO for the degraded soil for Malaysian context. How does they interpret our degraded soil? Because most of the countries, I believe, they reported based on their desertification. So which is Malaysia is tropical land. So if you know, what is our metrics for degraded soil?
Okay, so just to maybe there's a miscommunication here. Just to answer this question, Miss Intan, the work for the soil status of the World Soil Report comprise the 10 soil threats that I've shown in my slide. Okay, it's just that the avenue in the UNCCD will be used to launch the report. So what I'm trying to say here is that we did not do any metrics on soil degradation in Malaysia. It's just that the UNCCD meeting, which will be happening in Ulaanbaatar, where it's looking at land degradation, would be used as a window to launch the status of the World Soil Report, which comprises the 10 soil threats that I was talking about in this presentation.
Okay, Doctor, clear. I think we have about 1 minute before we can end up. And I know there's a lot of questions that we have not answered. So I think I have to get your agreement to try to answer these questions. I will send it to your email and then we will give it back to those who attended today because that's the intention of this Soil Connect. So thank you very much, Dr. J, for your time, for your explanation, and being the first speaker of our Soil Connect. So I think we
Th-
can.
Thank you, Miss Intan. I also want to say my gratitude to all the participants who have signed in. I saw like close to about 150 over, not bad.
Mm.
And I'm more than happy to answer your questions. I'm sorry that probably today I may not be able to address everything, but please, Miss Intan, collect the questions. This type of presentation, I know that it's creating awareness, and it's nice to know that there are more people coming forward to increase their awareness on soil health. Please keep on remembering that our existence in this face of the earth is owing to 2 to 3 cm centimeter of soil that is actually producing our agriculture food. Please remember that when you're doing anything to the soil.
Agree with you, Doctor.
Mm.
So thank you so much again to our speaker. And before we end our first webinar, I would like to remind everybody to check on the chat for the e-certificate link. If you need, fill in the Google form properly so that we can send out the e-certificate of your participation today. And also, I